we are partners to this project, together with the Heritage Management Organization from Greece and the Kharkiv School of Architecture evacuated to Lviv, Ukraine. We are currently implementing the project Preserving Architectural Heritage in times of war, the Ukrainian Model. It is supported by the public diplomacy section of the US Embassy to Ukraine. This project will contribute to the preservation and rehabilitation of the architectural heritage and documentation of archaeological monuments, architectural monuments, and strengthening the professional formation and providing on-the-job training for young Ukrainian architects. As part of this work, we are very excited to launch a series of webinars for students, young professionals, and everyone who is interested in digitalization of cultural heritage. Today, we have our first webinar in this series, and we are truly excited to see our amazing speakers and our amazing audience. As of yesterday, we have more than 150 applications from more than 30 countries of the world. So please use our chat to write your questions. We will collect them to put them to our speakers later today. So our first webinar today has the title From Digitalization to Global Interaction with Cultural Heritage. And we are dealing today with modern, up-to-date instruments of preserving cultural heritage, especially it is topical for Ukraine, because Ukraine has over 140,000 immovable heritage sites. And starting from 2022, more than 1,062 heritage objects were destroyed or heavily damaged by Russian aggression. For you to understand, more than 350 objects of heritage in Ukraine were digitalized during these 2.5 years, and this is, of course, a very small part of all the objects to be preserved and documented. During the aggression that Ukraine is experiencing now, it is very important to document these objects and to share them with the world. And digitalization allows us to see Ukraine, to learn about Ukraine in a safe way. And today, our speakers who are talking about the latest tendencies in digitalization will advise us what to do and how to work to preserve our monuments and share them with the world using modern state-of-the-art tools. And I would like to give the floor to our first speaker, Jakub Vanko. He is a senior technical product manager at Epic Games and the authors of the reality capture programmetry software. He is an experienced photogrammetry and 3D laser scanning specialist with a history of working in the geospatial industry and game industry. He's skilled in geodesy and GIS, remote sensing, image processing, and he's also passionate about 3D art and visual effects. I must say that as of 2022, at the start of the Great Invasion, we were provided with a license for the reality capture software free of charge. And then we managed to buy more licenses at a significant discount. And I am strongly recommending to you to learn about this. And as part of our project, students are now learning to use this software, and they are delivering amazing results. So I think we are walking the right way. And Jakub, you have the floor.
All right. Thank you. Thank you for the introduction, Yurko. Hi, everyone. So I'm Jakub, and I'll start sharing my screen first so you can see my slides. And all right, So today I would like to talk about a topic called From Reality to Virtual Worlds. And it's going to be about reality capture to Unreal Engine workflow. So first, I would like to introduce reality capture, what it is, what it's capable of, and then I would like to walk you through a real use case of scanning of a ruin of a smelting plant here in Slovakia. I will talk a little bit about the capture process, then processing of the data in reality capture, and then how I visualized it with the help of Unreal Engine. So first, both reality capture and Unreal Engine are products of Epic Games. Epic Games is a big, primarily gaming company famous for Fortnite. So some of you maybe play Fortnite, but it's also very famous for Unreal Engine, which is the top tool for real-time 3D applications, games, linear content, animations, films, and also maybe virtual tools, which can be also used for cultural heritage. So reality capture, for those who don't know, is now also part of the Epic Games company and also part of the Unreal Engine ecosystem. And one very important thing, since April this year, reality capture can be also downloaded from the Epic Games launcher, and it's free for students, educators, and also for individuals and companies that make less than $1 million annually. So I highly recommend you to download the Epic Games launcher, download reality capture, and try it yourselves. So, and I hope that after today's talk, you will have at least some information to get you started. So what is reality capture? So it is a software that is using photogrammetry and laser scanning, or the combination of both, to turn series of photographs and laser scans into high fidelity 3D textured models that can be used in Unreal Engine, Twinmotion, or any other digital content creation tool. It can be used by architects to draw CAD drawings, you name it. It is still the fastest photogrammetry solution out there, and it's capable of processing unlimited number of inputs. It's capable of creating unlimited level of detail. It's capable of reconstructing scans of tiny insects all the way up to castles and cathedrals, like you can see on this slide, which was made out of 111,000 images plus a couple of hundreds of laser scans. This is the Cathedral of St. Elizabeth, located in Košice, here in Slovakia. And this cathedral was scanned during a huge digitalization project of heritage here in Slovakia. And this is just one of the monuments that was scanned during this project. So before we continue, I would also like to mention that reality capture is used in the production of Megascans. Megascans is another product of Epic Games. It's the largest and fastest growing library of 3D assets and 2D assets, and it's being used by the top AAA game and visual effects studios. But why I'm mentioning it here is that these assets can be also used for set dressing. For example, when I recreated a scene that I will show you, I also used Megascan assets to populate the scene with vegetation, with small props that really bring the scene alive. Reality capture is also used in the production of metahumans as well. With the MetaHuman creator, you are able to create digital humans, animated digital humans, in a matter of minutes. And the preset characters that you start with are also based on scans of people, which have been generated by reality capture. And again, this is something that can be also used in virtual experiences. So you can have your own avatar in the experience, or you can have some third, let's say, non-playable characters making the scene alive. And to continue, so there's also a plugin called Mesh to MetaHuman. So you can actually scan your face. It doesn't have to look pretty, but you can use the Mesh to MetaHuman plugin in Unreal Engine to create your own MetaHuman and basically bring yourself to the experience. So what are we doing today? I would like to explore or guide you through the process of scanning and processing of this ruin. It's a ruin of a smelting plant. and it's located in the region of Orava in Slovakia, near the village of Podbiel. So I would like to give a shout out to this village because they were very nice that they gave me the permissions to scan this location and turn it to a digital twin. And since I scanned this asset, I had the opportunity to talk about this project in multiple different countries. And actually, I hope that I inspired some tourism as well, that someone will come to this location and explore it in a real world. So I will talk about how I planned the whole scanning, how I scanned it, how I processed it in reality capture, and then how I bring it to life in Unreal Engine. It's possible that maybe I will switch a few times between this presentation to actual reality capture, so I can show you a couple of buttons or how I do certain things. We'll see. All right, and here you can see a only small part of the render that I did in Unreal Engine with the path tracer. This is just a still frame, but the Unreal Engine is unreal and it's limitless. You can create a virtual experience. You can render linear content like an animation or a few photos. So let's get to the scanning and how I photographed this object. So first I did a little bit of scouting. I went to the location just to plan out what kind of gear will I need, because I mentioned that reality capture is able to create models out of photos and also with laser scans. Well, at the time I was not able to get my hands on a laser scanner, so I only had a few cameras at my disposal. So will be a mirrorless camera enough? Should I bring a drone? So that's what I'm trying to figure out during the scouting process. Also, are there any obstacles if I will going to use a drone? Are there any trees which I can actually hit with the drone? Well, which they were, and I actually did, but more on that later. Then also, if there are any bushes or some vegetation that could influence the quality of the reconstruction of the model. So all of this is being done during the scouting process. Then once I've scouted the scene, the location, I was looking for some good weather opportunities for scanning because in my case, I really wanted to have good textures without any baked-in shadows because I wanted to recreate my own lighting in Unreal Engine. I know that for preservation of cultural heritage, maybe this is not so important, but for me, this was very important to have textures without any shadows. So I was checking out the weather report, and once I've seen that there is a window of a few days with overcast day, I planned out my scanning trip and went to the location. So when I was on location, I used a mirrorless camera. It was the Sony A7R Mark V. Very fancy camera, but of course you don't need such fancy gear to get good results with reality capture. I also used a drone. It was the DJI Mavic Pro, also nothing very fancy. It was the very first generation. And I used it to scan some inaccessible parts from the ground. Besides that, I also used some accessories like a color checker because I wanted good textures. So also I used a color checker for calibrating the colors. I also used some scale bars for getting a proper scale. And I think that should be it. It was pretty light. Of course, you could use way more expensive gear like a laser scanner or a drone with a LiDAR scanner. But in this case, the gear that I had was enough to get a really good result. Right, so here is the summary. So as I said, Sony A7R Mark V. The lens was a Sony 20mm lens, a 20mm because of the wider field of view, which allowed me to scan more of the object. And since it's a 61 megapixel camera, I was able to capture the object relatively quickly. Next, also, I mentioned the DJI Mavic Pro drone, which only has 12 megapixels, but it was still good enough. I actually didn't use the full 61 megapixel resolution from the camera. I downscaled the images for faster processing. All right, scale bar color checker I already mentioned, but one important thing, I've captured all the photos in RAW. because RAW contains more data and it gives me more opportunity or more room for post-processing the images. For example, like tweaking the white balance, exposure, etc., contrast. Basically, in this case, I wanted to have flat images, so the texture is delighted and I can light the object in Unreal Engine. All right, so once I've captured the data set, it was around 900 photos in this case, which is, I think, a reasonable number for this object. It wasn't really that complex. And for processing in reality capture, it goes like this. So first, the alignment of the photos from the mirrorless camera and also from the drone. This process is fully automatic if you followed all the rules. Basically, every single point of the object needs to be visible in at least 2 photos. There needs to be high visual overlap between the neighboring photos. So if you follow all of these rules, then reality capture is able to create a single reconstruction with all the cameras in one single component. Next, so I've created a model. But there were some issues with the model on the backside of the ruin. And why is that? Well, it's because I crashed my drone and I was not able to finish my flight. So the backside of the ruin was not captured as it's supposed to be. So that's why I had some issues. But reality capture has some tools that allow me to fix these issues. By the way, the drone was fine. It just took me around 15 minutes to find it in really, really tall grass because the fans of the drone, I could still hear the fans of the drone, so I was able to find it. So once I fixed these misalignments, then I could continue with the model calculation, with the cleanup, unwrapping the model, texturing it. And because reality capture creates really, really dense meshes with millions and hundreds of millions of polygons, I've also did some simplification and texture reprojection in order to run in real time in Unreal Engine. All right, so for aligning the photos from the mirrorless camera and the drone, all you need to do is just drag and drop the photos into reality capture, and that's it. You will just press one button, which is called the Align Images button. So during this process, reality capture is trying to find some contrast features in the images. And then it's trying to match and pair these features to neighboring photos. And based on triangulation, RC is able to estimate the 3D positions of these features, but simultaneously the intrinsics and extrinsics of the camera. By that, I mean distortions, etc., but also the positions and rotations of the cameras. So once we have this, we have it, but there were some issues, and I had to fix these issues with control points. So what control points allow me to do is basically create manual features, to say it as so simply, but you need to find some feature in the photos that your eyes and your brain can recognize in multiple photos and mark this feature on multiple photos. And that way you are able to correct the misalignment. So I hope that you can see my mouse cursor. Can you? Yes, okay. Yurko is nodding, but yes. So here you can see that on this side, the coverage of the ruin was really, really precise. There was a lot of photos, but here in the back, because of the tall grass and the trees, and because I crashed my drone, I was not able to do the same thing. So this is the problematic part. And these cameras over here are all shifted, misaligned, and that caused the mesh to look really, really badly. So in that case, I decided to use 3 control points. I decided to place one on the left side, one in the middle, and one on the right side. What's important is to mark these control points in photos, both from the drone and also in photos from the ground as well. And ideally from multiple angles, so there's some parallax between the images. And the parallax will cause that we are able to triangulate the control point better in space. So once I did this, I just realigned the entire project, and the result looked like this. So if you take a look at the photo, notice how the cameras shifted. Okay, I'll do it a few more times. And finally, I've noticed a huge difference. And also, once I remeshed the model, it was looking okay. But before I reconstructed the whole thing, I just focused a reconstruction region just to this problematic part. And I didn't even use the highest detail for the calculation, just to save time to get proof that, okay, the problem is fixed. Right, so next, I've calculated the model. It's just another push of a button. During this process, reality capture is first calculating the depth maps for every single photo. That means that it's trying to estimate the depth of every single pixel. This process is the most intensive one. That's when your fans are going really, really loud and the computer is producing a lot of heat. And this process is then automatically followed by the model generation. So the actual surface of the mesh is being reconstructed. Once it was reconstructed, there were some parts that needed fixing, mainly on the top of the building because of some vegetation, mainly some tall grass that was there. But reality capture has tools to actually select these parts and get rid of them. You can use the lasso tool to select the parts and use the filter selection tool to get rid of them. And the advanced tool is really cool because you are able to select really, really tiny floating parts of geometry around the main part and filter them as well. And to get rid of the ground, I use a tool called the cut by box because it makes a nice clean slice, which really looks good in visualizations. All right, so after I had my mesh, I continued with the unwrap and texturing. And you can see the settings on the slide because by default, reality capture is creating only one 8K texture. If you want to get the best possible texture from the source images, you have to change the texturing style to fixed texel size and the texel size to optimal. This way, reality capture will generate as many textures as needed to get the best texture quality possible. In this case, it was 18 or 15 8K textures. And I did it in two separate steps. So first I did the unwrap. RC estimated that yes, it will need 15 8K textures, and then I proceeded with the texturing of the model. All right, so once I had my high poly mesh textured, it was around 95 million polygons, and still it was only calculated in the normal detail, not the highest quality. I decided to go a little bit lower to bring it to Unreal Engine. And I decided to have two versions. So my second high poly or mid poly, let's call it, I reduced it to 50 million and just baked down the color with the texture reprojection tool that is available in reality capture. Then I decided to create a proxy mesh just for setting up the basics of the scene and the layout. So I simplified to 5 million polygons, and I used the texture reprojection tool to bake the color, but also the normal map as well. And the normal map is basically faking all the detail. Right, so that was the process in reality capture. The most manual labor part was fixing the asset with control points. And that's the reason why the input data really matters. If you have the data properly captured, you have proper coverage of the entire object, then processing in reality capture is really just a matter of a few buttons when you don't have to fix anything. So for the setup in Unreal Engine, I'll show you some reality capture export settings, Unreal Engine import settings, and I'll walk you through the asset setup, placing the asset in the scene and finishing the scene. So for the export, since I'm staying in the Unreal Engine ecosystem, both Twinmotion and Unreal Engine is using FBX most of the time, and also all our internal teams as well. So I decided to go with the FBX export. And here are some of the settings which are important. So for the big one, for the 50 million poly mesh, I decided to save mesh by parts. What are these parts? So these parts are internal parts used by reality capture when the mesh calculation is going on in order to fit everything into VRAM. So I decided to export these parts. So it's not going to be one single mesh that is 50 million, but it was a bunch of smaller meshes, which are easier to work with and to import. Export vertex normals, yeah, that's great because of it's preserving the smoothing. Export vertex colors, no, because I'm not using the vertex colors in Unreal Engine. Export materials in this case, yes. Tile type, that's the default one, U1, V1. And finally, the most important, I would say, transformation preset, which is Unreal. And this will ensure that the model has proper scale and orientation in Unreal Engine. So that was for the big one. For the small one, the proxy, there are a few changes. So in this case, it was not saved by parts. It was just the one huge mesh. And the other settings are the same, except the tile type, I decided to go with UDIMs. No, I won't get into details, but what's the difference between the U1, V1 and the UDIMs? So U1, V1, Unreal Engine creates a material per texture set. So there was 15 or 14 8K textures, so there's going to be 14 materials. With the UDIMs, I will have just one single material, and all of these UDIM tiles, these multiple textures, will be linked to that material. And again, the transformation preset was Unreal. So now the import to Unreal Engine. And in the beginning, I recommend you to reset to defaults. And the only thing that you have to change is the convert seat units to yes. And this will ensure that once you import the model to Unreal Engine, it's going to have the proper scale. For the small mesh, I recommend to disable the import of textures and just import the first tile of the texture set. So UDIM tile number 1001. So if you are having some visual glitches, mainly in the texture, maybe some blurriness, some distortion, these are the settings that can actually help you solve it. So go to the details of the static mesh that you just imported and check use high precision tangent basis and also use full precision UVs. So if you have any issues, this will fix it. But this was usually for meshes that were not nanite. In the default settings, here it is already checked that import the mesh as nanite. All right, so for the asset setup, for the big mesh, the material is created automatically. But since we have a lot of small parts, what I like to do is just create a blueprint. And this blueprint will encompass all of the small meshes. So I just created a new blueprint class, actor class, and added all the small mesh parts to this blueprint and compile. That's it. No coding or anything. And now if I would just drag and drop this blueprint into the level, it would act like a single mesh. For the small mesh, since I was using UDIMs and I also disabled the materials, I had to create the material from scratch by myself, but it was very, very simple. I just drag and drop the textures to the material, the color to the base color, the normal to the normal, apply, save, and that was everything. Now I had just to apply the material to the mesh. So for placing the scene into, placing the asset into the scene, so I just drag and dropped it. And here are some just numerical values. So I remember where I actually placed the asset, because the terrain that you can actually see, that was another source of data. I actually downloaded some LiDAR data of that location and I meshed it into a surface and I imported it to Unreal Engine. So this is like the real replica of that area. And I just painted some grass in Unreal Engine and I painted some trees as well, just to make it look a little bit more real. And if you want to get the highest quality of your renders, I recommend using the path tracer in Unreal Engine. So for that, you need to enable ray tracing for the project. And also there are some console variables that you need to use to get the best quality. Those console variables are on the slide. It's mostly related to ray tracing and also forcing the levels of detail. Yep. And then I was able to just hit render and get this, I would say, pretty nice image. I'm not an artist, so please don't judge me, but I try to do my best in a really, really short amount of time. So that is for my part. Happy to answer any questions, or we can continue.
Thank you very much, dear Jacob, for this presentation. I remember you said here that you were waiting for the right weather so that there would be no shadows. I remember a friend of mine who is also dealing with digitalization. He made a joke. If the day is gloomy and you see a person running somewhere with a camera, this is a photogrammetrist who is running somewhere to make some scans. So I would like to remind everyone that our chat is open for your questions, so please write your questions in our chat. I have a few questions, and I will use my right of the moderator to start. For me, it is very interesting to ask whether what are the prospects from reality capture in 2025? Maybe you could actually give us a look further on, maybe, so if it is not a secret.
Okay. Yes, and actually, the good news is that you won't have to wait until 2025. So for next year, we have one more release planned this year, which is coming really, really soon. And there's going to be a bunch of updates, a couple of new features. I can mention speed ups in texturing, and for big data sets, extreme speed ups of texturing. The whole texturing code was optimized, so you can look forward for that. Especially when you are trying to texture large assets like this ruin or cathedrals, when you're making a lot of tens or even hundreds of 8K sets, texture sets, so you can really expect large speed improvements. Then we added a couple of new exports. For example, a long waiting colmap export as well is going to be included in RC 1.5. What else? There's also the USD export as well. And yeah, let's say that you can look forward to this release. I think that I already said enough.
Thank you very much. We have a question from the chat, and it is a bit philosophical. So, which scanners or what kind of equipment will be better for small objects, and which scanners would be better for big objects, and whether there is any difference for the final 3D model to use a specific type of scanner?
Okay, if we're talking about laser scanners, so that's a whole different topic because there's a really huge price range. But I'll get to that as well. But regarding cameras, what I say is that the best camera is the one that you have, and especially when you want to take a photo of something, so you can actually get decent results with a phone. Yeah, really. If you have a good phone with a good camera, you can get decent results for small objects without any issues. If you want to take photos of professionally for projects like this, digitalization, so I would say the full format, full frame cameras are like the best bang for the buck. There are also medium format frame cameras, but they are more expensive. They are much harder to work with, but on the other side, they provide you greater resolution. So, but I would say go with the full frame, like the one that we have, the Sony A7. We use them. Quixel uses them as well for scanning smaller assets, small props. For the lens, I really recommend you to get really good lens, good sharp lens. We recommend always to get prime lens. because of all the calibrations, etc. But internally, we also use zoom lens as well because they're more versatile, because sometimes you need 20 mil, sometimes you need 50 mil. But when you're using this variable lens, I recommend you to just set one zoom level and stick to it throughout the whole thing. Reality capture can handle this even if you mix and match different focal lengths. Even in this case, so I had the drone, which from the Mavic, it's really very small focal length, but when it's calculated to the full frame, it's 24 mil, and the camera that I used, the lens that I used on the camera was 20 mil, so pretty similar. I started out with a crop sensor, and I was able to get really good results. And regarding laser scanners, well, yeah, you can get a decent terrestrial laser scanner, let's say around 20K, but it can go all the way up to 70K without any problems. But you can notice the difference. You can notice the difference, especially, for example, in speed, density of the point clouds, quality. I hope that I answered your question.
Yes, and thank you. I would like also to add, reality capture once published one thing together with a researcher who scanned insects. And if you have a good microscope with good resolution, you can actually scan insects, but you need to understand what you are working with. Reality capture can be used in various scales. And I remember that what was the name? The research module which landed on Mars, we immediately got like 100 3D models from Mars as soon as we got the pictures. So we have the ability to use Unreal Engine with different objects. And there is a very interesting question from our students. Students are using all sorts of PCs of notebooks, and not everyone has NVIDIA. So, and I think Jakub, you already understand the question. Do you support other video boards, not just in video?
At this time, like the whole meshing and texturing was written specifically for CUDA, so for NVIDIA. But for students that do not have NVIDIA GPUs, I recommend them to start out with our other product, which is called Reality Scan. It is a mobile application which is also free for downloading. It is available both on iOS and also on Android. So you can take photos. There's a limit of up to 250 photos, but with 250 photos, you can get decent scans of smaller objects. So it's not designed for scanning buildings, even though I've seen successful attempts. Then once you take the photos with the application, the photos are uploaded to the cloud where the processing happens. So basically an RC running in the cloud. And then once it's processed, you're able to get the result to your phone. You can download the model to your phone or share the model on Sketchpad as well. So this is the beginning. And yeah, so this is the beginning, cloud processing.
We have a few more questions. I will be unable to voice all of them now. We are collecting all the questions, and if I skip something, I think we will answer by email. So the last question: during the last decade, what was the major influence on digitalization in the world? What would be the key changes that you have noticed during the last decade?
What I've noticed in the last decade. That's a good question. Well, definitely, like everybody's talking about AI, let's say. AI this, AI that, prompts, generating of 3D models from prompts. But this is where we say, like, we will still need to digitalize real world objects. So, and you can say like maybe generate me an Eiffel Tower, but maybe it will be able to generate something out of photos if there's enough photos, but we will still, I think we don't have to worry. We will still need to scan real world objects. Definitely. I mean, AI will definitely help with generating 3D models for some use cases, but for digital cultural heritage, we still need to scan the real stuff. And in terms of technology, of course, we have more powerful hardware, we have better cameras, we have better laser scanners. So the speed of data acquisition is way faster, and also the processing. Then I would say there was a huge progress in visualization of the data, but that's something that I think Thomas will talk about more.
Thank you very much for your question, for your answer, sorry. And finally, I would like to add, AI can do a lot, but it would be great if it could understand that the window is a window and a wall is a wall. And I think photogrammetrists will agree with me. And the last thing I would like to say, reality capture, I learned when I was a student, and then I was absolutely captivated by its potential. Once before it, I could spend like 8 hours to calculate something, because I was a student of geodesic department, and you know, in the morning I would find out that I did something wrong and I need to start again. So, but reality capture compressed this 8 hours to 30 minutes, and photogrammetry became not just waiting for something which you don't know what would happen, but it became a real moral satisfaction, and which led to Skeiron, to my company. And today, thanks to that, we have a lot of objects scanned in Ukraine. Thank you very much, Jacob, for your time. And let us move to our next speaker. So today we talked about digitalization, and let us talk now how to use it, how to allow even the smallest museum in the tiniest village could become popular and could get hundreds and thousands of subscribers and visitors. So our next speaker is Thomas Flynn, and he works in the field of cultural heritage, specializing in 3D digitalization, online publishing, open access, storytelling, and interoperability. He is providing expert advice on the topics to UNESCO, to European Commission, to Oxford University, Creative Commons, UK Research and Innovation, Columbia University, University College London, and many, many other organizations. He is also a co-chair of the FFF 3D Community Group and on the advisory committee of the Rijksmuseum in Amsterdam. He is also a co-founder of the Museum in a Box, and he once was a cultural heritage lead at Sketchfab Epic Games, where we found him actually. And he also is digitalizing British Museum. Thomas, you have the floor.
Thank you very much for that introduction, Yuri. I'll just share my screen as well. So yes, thanks, Jakub, for that presentation. It was really interesting to see an inside view of reality capture. And thank you to the organizers for having me along today. I'm going to be talking about a lot of different topics, as we'll see in a second. It's really to give context to some of the more technical discussions that we've already heard about. So I won't introduce myself again, but the presentation that I'm showing is there's a link, a public link, and you can go through the presentation slides and follow the links if you're interested in any of either my work or any other of the projects that I will be demonstrating. My goal today then is to introduce everyone to some ideas and projects that I hope will inspire your own explorations of what is possible when you're working with cultural heritage content and looking to digitize it and publish it in 3D. There is a lot of content in the slides, so they may go quite fast, but as I say, please do consider looking at the slides themselves so that you can explore in your own time. To give a quick idea of what I'll be going through, first looking at some trends and initiatives in the heritage digitization space, then some considerations for heritage digitization, considerations for online publishing, looking at some examples of open access and interactive storytelling to finish. So there are many related topics that we can talk about when we think of 3D digitization publishing for cultural heritage. I'm not going to go into all of these now, but just to put into context that we may be talking about one specific technology or one specific use case for a technology, but there are many other related pieces of technology and initiatives and ways of using 3D that exist and many people are working on across the sector. Some of the themes that will be evident in this presentation are interactive games, interoperability, digitization in the context of the climate crisis, storytelling, and a few others. It's also important to understand that 3D digitization for cultural heritage is an evolving field of activity. There are no strict rules about what can be done and what should be done. There are few agreed standards in practice across heritage organizations and different countries when capturing and publishing 3D data. So there is a really big opportunity for creative research and development in this area, should you consider looking into it a bit more. So to begin, I'll take a step back and just consider some ideas around digitization or digitalization. Before we begin digitizing something, I think we should always define our audience. It really gives us the why for the data we are capturing. Instead of just going straight to capture anything and everything, it can be helpful to consider whether you are creating content for example, young students or academics, or for creators and artists. So starting with who the data will be for is a good place to begin, and that will help dictate what needs to be captured as you are capturing a particular space, place, object, or subject. And then different audiences, whether they're academics, the general public, students, and creatives, will be ready to receive the right kind of data that you have produced. And throughout all of these audiences, it's important to consider accessibility. So how will people with different abilities engage with that data? So for example, whether they have some kind of visual impairment or cannot necessarily use certain input technologies, how will they access the data as well? I also want to just get everyone thinking about the idea of what is good 3D data. So a comparison here, we heard from Jakub just now, the idea of being able to create a 3D model just using your smartphone compared to some high-level expensive equipment used to create, for example, a 3D model for building information modeling with different levels of development or detail. So we have two kind of ends on the scale of quality of data. But in both cases, we can have good and bad data depending on what our goal is. Some data will not be suitable for certain audiences. And also, just because something has been captured on a smartphone doesn't mean that that 3D data is necessarily worse or useless, because it may be, for example, the only 3D model that has ever been created of a particular subject. And once that real life subject is lost or destroyed, then we may only have one record of it, because it could be captured quickly and easily. And then lastly here, I want to indicate the idea of holistic digitization. So when we are capturing a subject in 3D, obviously we are capturing the shape and the color of the object. But at the same time, during the digitization project, you could also be capturing the history of that subject, capturing the voices of the people and the stories of the people related to that subject, even the sounds, the smells, the movements. These are all part of digitizing a subject. And even on top of that, it should be considered that every time you are working on some kind of digitization project, you also should record who is digitizing it, why you are digitizing it, what equipment you are using. And this will, for example, help academic users understand the quality of the data if they retrieve it at a later date. They can understand exactly what they are looking at, what maybe is an error in the data, and what is the real data. On the other end of the scale, then, I talked about kind of quick and easy 3D scanning. So we are in an age where everybody has a 3D scanner in their pocket. If you can take a picture on your smartphone, you are able to create a 3D model. It's really that easy. And what does this enable? It means that there are hundreds and hundreds of people out in the world capturing subjects that relate to the culture and history of the human species, and they're uploading it and publishing it online. And this data exists somewhat outside of the museum and heritage sector, but it still has value because, again, as I say, it may be the only capture of a certain subject that exists. So it's interesting to consider what could engaging with these citizen digitization experts, let's call them, to capture certain subjects or to enable digitization, for example, when there is no budget or there's no funding. And then what can we do with the data that they are outputting and publishing when we look at a regional, at a national, and at a global scale? As we are creating data, we can consider the sustainability of that data. So this can be interpreted in two ways, or I will interpret it in two ways. One is the long-term access and availability of the data we capture. So if we digitize a building today, where are we going to store that data so that in 100 years, 200 years, that data is still available for people to access and use? So there are some national data repositories that exist, and projects like Open Heritage 3D, which is a consortium of organizations accepting deposits of 3D data from around the world. Another interpretation of sustainability is the ecological impact of 3D digitization. So it's important to not talk about 3D digitization for cultural heritage without the context of the world we live in. So the fact that there is a climate crisis happening, we should consider how does the use of technology contribute to real world problems, and how can it be optimized to have the least impact. It may also be about capturing the effects of the climate crisis as things change, as geography changes. How can that be recorded and used to interpret what is happening to our planet? I'll move on now to online publishing. There are, as I say, many more things that we could talk about in each of these areas. So I just want to give you a flavor and some things that I think are interesting. When we publish 3D data and metadata, so the metadata is the explanation of what is the file, who was it made by, everything about the digitization project. When we combine 3D data, metadata, and the internet, this provides a huge opportunity to enable wider interactions, dissemination, and discussion around the data that we are publishing. And then there is also a challenge regarding maintaining the heritage context of that data, because as many people will have experienced online, as soon as something is online, it will be used and reused in many different ways, and can be divorced from the heritage context that we're perhaps trying to establish when we put it online. We maybe can mitigate these issues by having a source of truth, those national level databases where people can always refer back to get the true story of the data that we are publishing. When we publish 3D data online, we must prepare that data for an online audience. We must optimize that data as much as possible. The lighter the 3D files that we publish online, the faster it will load for audiences and users, the better the performance will be on more devices, faster downloads if we're allowing people to download that data, and it's more accessible to a wider portion of the internet using world. If you want to give people access to the high resolution data, so the full quality data sets, do this. You can provide that link, but the data that you show to people, it should be optimized so that it will run on a smartphone, on a laptop, on any kind of display device. It will simply be a better experience for your end users. And so to illustrate that, this is a very simple diagram that the more complex your data becomes, the larger the file size, the ease of using it and reusing it declines, and the audience size is reduced. So whereas high resolution data may be more useful to, for example, an academic audience, optimized data will be much more useful to the wider general public. This is just a very simple example of that. So we have two 3D models here. One of them is 73 megabytes in file size, and the other is 3 megabytes in file size. And it's, I think, quite difficult to tell the difference between the two. I'm not going to even explain which is different, but the fact is that we want to introduce people to our data in a pleasant and enjoyable experience. And if somebody has to wait for 5 minutes for a web page to load when they're downloading our data, they will get bored. They will do something else. Attention spans online are, especially for the general public, maybe it is different for academia, but attention spans can be quite short. There are many, many different ways that we can publish 3D data online. So this is just a snapshot of some places that you can publish your 3D data. But it's important to consider, again, the audience. Who are we trying to reach with our data? Also, what resources do we have? Some of these services are self-hosted, meaning that you would need an IT department or some knowledge of web technology to run them yourselves. Some are non-profits, and some are commercial companies. So you should understand how the services work, and also the end user license agreements that you are getting into when you use these services. So it's not to say any of these are better or worse, just that it should be understood that they are different and have different use cases and different audiences. Publishing data, when we publish data, we can use something called a FAIR principle. To begin with, this simply means that we make our data findable, accessible, interoperable, and reusable. So that's the core FAIR principles that people can, for example, perform a web search and they will discover your data. They can access the file itself and it will work on their machines. The data can be used in different software environments, and there are licensing agreements in place that allow people to reuse them. I've added on 2 extra letters to this, E and S. I believe that how we publish data should also be engaging. It should get people excited not only about the 3D data they're looking at, but about the story, about the history of the subject we are presenting. And again, to go back, we should ensure that how we publish 3D data is sustainable so that it will be available in many years. There are a couple of links on this slide that you can follow. The AAAF 3D community group is one of the groups I'm a co-chair of, looking at interoperability between 3D data collections across heritage organizations. Speaking of publishing data and making it reusable, there is a growing movement called Open GLAM or Open Access, which makes 3D heritage data available for download and reuse under some kind of permissive license. So if we are choosing to do this, we must acknowledge the rights of the subject that we are publishing. For example, do I have the right to digitize something and publish it and give access to everybody around the globe? Because when we do submit data under an open access program, we effectively relinquish control of what happens to that data. It's difficult to make 3D data available for free download, but also to tell people what they can and cannot do with that data. But I'm a big believer in open access, and I believe that it increases participation and engagement, especially with cultural heritage content, whether that might be academic reuse of 3D data in educational environments or creative reuse of 3D data in, for example, renders, video games, and other creative areas. And then, of course, 3D printing allows people who may not be able to, for example, see a particular subject to touch and experience that subject in a physical way. I'm going to finish my presentation just with some examples of different ways that people have been publishing interactive storytelling online. So again, there will be links in these slides for you to go and click through, because I can't take the time to really show you exactly what they're all about, but I want to share them with you. The first archetype of storytelling I want to share is the idea of scrollytelling. And this is a way of presenting 3D data on a screen, whether that's a laptop, desktop, or smart device. And the only interaction required from the user is to scroll the web page. And this will change the viewpoint on the 3D model. It will present new content. And some really great examples. The image here is from the International Committee of the Red Cross, their Broken Cities website, documenting cities that have undergone the effects of war and documenting the stories of the people who live in those cities. There's also examples from the New York Times about Notre Dame in Paris, which was destroyed by fire not too long ago. And also the Getty in the US has another great example of scrollytelling. I added this just at the last minute because I was reminded of it by some of the previous discussion, but Street View is also another kind of 3D spatial way of engaging with heritage. It's been around for a long time, but it's still popular, and there are new features. For example, we can see here using annotations to provide more context to a visual tour. And this is a quick example called The Abandoned Village of Lifta by Karim Yahya and Open Virtual Lands, a group who are documenting, in this case, a village in the Palestinian district of Lifta, which has been abandoned after occupying forces forced people out. There are many more ways that we can engage with data instead of just on a screen or something in our hand. We can view things in augmented reality. Some great examples are the Notre Dame de Paris augmented exhibition, and in general, the work by Histovery, which can reveal the kind of hidden history of a space or a place using virtual tablets, or rather they're real tablets and virtual content. And then there's a nice prototype that a technologist called Andy Agus presents, where he's wearing a virtual reality headset on a visit to the Metropolitan Museum of Art, and we can see that it's revealing more information about the subject that he is looking at. Speaking of headsets, virtual reality can also be used to teleport or transport a user into another time, another place, another experience. The two examples here are from Targo, a project called Through Their Lenses, which was developed based on World War II photography collections. And then more recently, there's an announcement from Meta, the developers of the of Facebook and also of the MetaQuest headsets, which has enabled something called, they call it Horizon Hyperscape, but it's essentially a way to digitize spaces in 3D and then present them in virtual reality for exploration at high detail. There are also really nice examples of maps and geolocated data, so telling stories through a zoomed out perspective on a location. So there is, for example, the Hiroshima archive, which maps stories of people who were affected by the destruction of the city at the end of World War II. And then some other examples from Cesium and also Google Earth Studio. So different ways of presenting the same kind of data, 3D data, in a different aspect. We can also, speaking of making our data available for reuse, we can present our data in gamified scenarios. So there are examples here from Fortnite and Roblox, which are two user-generated content platforms where experiences have been built at the top there to educate people about the pyramids of Giza or the missions to Mars, a more science-based experience. And then a nice example of reusing open data by puzzling places, where it's a 3D virtual reality jigsaw puzzle, and the subject here is the Hints Hall from the Natural History Museum in London. That's kind of the end of my presentation. There are a few other things that I just wanted to indicate, but I couldn't find a good place to put them. But I think they will be of interest to anyone exploring 3D in the cultural heritage sector or architecture sector. So Gaussian splatting is a new 3D rendering format, and it's particularly applicable to subjects that are tricky to digitize in other ways. So photogrammetry or laser scanning may not be as effective at digitizing, in the case of the pictures you can see, glass or transparent subjects, or very fine detail subjects like biological specimens and plants. There are also a couple of 3D file format initiatives that are worth looking into. USD and GLTF file formats are gaining or have gained industry support for their interoperability. And this is not just industry support within the cultural heritage sector, but across industries, whether that's automotive, film and TV, visual effects. These 3D file formats are fairly new and are being developed so that the data that we publish can travel between software environments quickly and easily and as we want it to. And finally, to go back to what I was saying at the beginning of the presentation, is that every day, every month, people are publishing new interactive and storytelling experiences with 3D content. And there's always going to be room for development and pushing the boundaries of what's possible and the stories that we tell, especially underrepresented stories using these technologies. So it's definitely something to try if you haven't tried it before. So thank you very much for your time.
Dear Thomas, thank you very much for such a huge presentation. And actually, this is just a very small part of what Thomas presents on his webpage. And I suggest you subscribe, because as soon as something new appears, it will be there. So this is my prompt to you. I have a few questions to Thomas. So what is especially interesting for me, there are so many online viewers, and many of them are rather private, so they are not open access, right? So Open Heritage 3D, CyArk, developed by CyArk, it is a very interesting kind of software viewer, and here the question will be the following. These private 3D viewers like Sketchfab, Nira, like Matterport, Tour, whether this state on the national level should support these initiatives if they want to publish, whether the state, the national level should compensate the publication of their own nationally important objects, or maybe the state should contact directly such organizations supporting the viewers, so that specific organizations, country-based organizations, will have the access to publishing.
Yeah. I think if anybody is using, for example, a commercial company's product, then they will pay for it in some way. So whether that is through a paid subscription using money, that buys the service, and I can recommend that. If, for example, a service or product is free, there is a saying that if it is free, you are the product. So that to me means that if you are using a service for free, there must be some other value exchange occurring. So that, for example, when I worked at Sketchfab, we offered free subscriptions to cultural heritage organizations, and I believe they may still be a project like that going at Sketchfab. But what the publication of heritage and cultural data on Sketchfab really increased the public awareness of the Sketchfab platform, and also it differentiated Sketchfab from other platforms which were maybe more focused on existing 3D communities who are 3D artists, video gamers, or architects. And I think it depends always which audience you are trying to meet with your content, because there will be audiences that use Sketchfab, there will be audiences that use Nira, other products, and it also depends on what resources you have for supporting your own, for example, open access 3D viewer, as I mentioned. I think ideally, every state in the world, every country would have a national level database for the cultural heritage data that is being produced, that would record that data sustainably, but also allow that data to travel to these other services to reach different audiences. I think state bodies shouldn't necessarily use just one platform to store their data and make it available, because if something happens to that platform, then the data may be compromised. But to have a secure core storage of the data and then copy it to as many places as possible to reach as many people as possible, and hopefully keep the heritage context as well.
Thank you very much, Thomas, for your answer. And I'm actually ready with the next question. You have been a consultant to such eminent organizations as UNESCO, European Commission, and can you share what countries are the most advanced in digitalization and structuring of heritage objects data and making them public? Which are the best, which provide the best access to such data?
I think there aren't many examples at a national or government level, but there are some very good projects in different countries. I made some notes earlier so that I wouldn't forget. There's some nice work being done by the Centre Monuments Nationaux in France. So that's the body maintaining all the large physical monuments in France. The Virtual Museums of Malopolska in Poland is another project I've always been a fan of. If you can find more information on how they operate, I think it's really interesting because it is a regional digitization hub that 40 different organizations make use of to send their content to be digitized. There's also Giravolt in Catalonia, the Moorbase Virtual Museum in Portugal. Here in the UK, there's a great project run by Historic Environment Scotland that's based on something called the Ray Project. They do wonderful work digitizing Scotland's built heritage and then for conservation, but they also maintain a very active Sketchfab account where they promote the sites and the stories of the heritage. And then there are other programs like 3D Icons in Ireland and the Institut National Patrimoniului in Romania. So there are many examples that I can encourage people to investigate. I can share these in email afterwards. But it's almost not the states or the countries who are doing the work. It's the heritage organizations, whether they're a museum or a regional project. And I should, of course, say that Skeiron's work as well is a really great, and I mean that, I really mean that, that the amount of attention and the partnerships that Skeiron has built around the high quality 3D content is a great example of how to do 3D for cultural heritage.
Well, I'm practically, you made me cry, you made my day, thank you very much. And we are very proud of being able to scan 150 objects during the 2 years. But I would like to say that before that, less than 50 objects were scanned, fewer than 50 objects were scanned in Ukraine. And in Europe, they digitize because they want to make it public. In our country, we digitize because we are afraid that it would be it would be destroyed by a missile. And so we have the storage space, and of course we are sharing on the internet because we need to share, otherwise we are lost. But I would like also to ask you another question, if it is okay. When we started this active digitalization, we learned that there is no list of recommended guidelines in terms of what objects to digitize. And we got some first letters from Poland, and they gave us guidance, and we adapted them to our Ukrainian reality and started to use them as guidelines. And this means that in Skeiron, we see there is a need to guide the people in terms of standards, how to digitize. And we decided to make this digitalization ABC, where we're going to talk about laser scanning, photogrammetry, including multi-spectral, multi-platform, AI, property rights, things like that. So, and we would like to understand what other points you believe could be important at the basic level as at the ABC level, not to make it like advanced, but to make it a short guideline where to look, what to do.
Yeah, I think this is a common experience for anyone working in digitization for cultural heritage, and I think this ABC project will be a valuable resource for not just people in Ukraine, but globally, to kind of have an overlook of what's required or can be done in this area. I made some notes on this question as well. I mentioned earlier about audiences and kind of the understanding of different data for different audiences. I think this is one thing that should be a common thread through all of the activities you mentioned. Also, this is more practical, but around project management, everything from teams, how do you structure a team to digitize content? Who do you need? Do you need a historian, a photographer, somebody to process the 3D models? And that also then moves into budgeting and finance and things like that. I think it's very difficult to do anything without people and time and money. I mentioned again in the presentation, long-term data storage. So thinking, 100 years when we are all dead, what's happened to the data? Is it still available? Sustainability, I mentioned as well. Some perhaps other technologies like digitization processes, for example, photometric stereo and RTI are processes for digitizing highly detailed, often flat surfaces. So, for example, textiles or other subjects, maybe even motion capture, because there's a concept of intangible heritage. So, for example, things like dancing or craft making, how is it possible to digitize those in 3D as well? Alongside, I mentioned audio and stories as well. Probably, yeah, looking at, well, how do you then, when you have all the data, how do you present that in an engaging storytelling method? Are you using augmented reality, virtual reality? And maybe it's not about teaching each of these things, but to just make sure people are aware of all the options.
I absolutely second that you really need to show to people that yes, it is possible, because there is the case when people are not aware about the possibilities. And I can see this in my students who are now being trained under our project. So the students who got a new tool to use, they already changed their thinking. I have an example when one of the students of photogrammetry, he understood it, he loved it, and in Kiev, just think about it. In Kiev, he made 15,000 photos using his mobile phone. So 10,000 on his mobile and 5,000 using his drone. But I mean, we impressed him, and I actually advised him to take a laser scanner, but that's a different story. And it is very important that people are inspired. The new architect, the young architects will go into industry. They will understand that they do not need to limit themselves with drawings. They will be able to work with volumes. They will understand the 3D better, and this will launch an avalanche when one small snowball actually engulfs the whole world and everyone understands what digitalization is. So allow me to summarize on the example of Ukraine. During the latest decade in Ukraine, the number of organizations who are engaged in digitalization has grown from 3, Odessa in Kiev, to a dozen, and all these dozen is working, and it is very pleasant to follow the activities. So I think, well, we are ready here to wrap up our today's meeting. We are really very glad to have such a big audience today. We're very glad to have this chance to communicate. I'm grateful for your questions. I could see Jakub actually answering during our meeting, and we will collect all your questions, and we have your emails. We will answer to you by email. At once, I would like to make a short announcement. On the 22nd of November, at the same time, we are having our next webinar. We will invite people who have been digitizing the world for more than 2 decades, CyArk. And if we have gained our experience during this several years, they have been gaining the experience for 20 years already. Thank you very much, dear speakers. Thank you very much, dear guests. I guess we need to finish here, and thank you for such a pleasant Friday evening.
Happy to be here. Thank you.
Thank you for having us.
I'm going to be here till the very end, so you may switch off. Thank you very much. Those who are done, you may leave the meeting. Thank you very much for your participation.
Ну що,